So we concluded our stuff on measurement yesterday. We had a redo of our calipers and micrometers, and we looked at our scales and determining what the divisions on scales stand for. Today we're going to switch gears just a little bit. We're going to go from measurement and do a little bit of algebra. We're going to talk about things that look like this. X equals 6, of course, is an equation. And the key to understanding this and how it works is, of course, that symbol there, which is the equal sign, right? What does it mean? It's kind of tough. Everyone says, well, it means equals, right? It's kind of hard not to define it without using the word. What it means is whatever's on one side has exactly the same value as what's on the other side. In fact, you can think of it as like a balanced scale that balances around that equal sign. The x and the 6 exactly balance each other. They have the exact same value. Now, all equations start out in this form as a variable equals a number, or a number equals a variable. And they are built up from there. One thing we could do to build onto this equation to make it more complex, we might be able to add something to it. Somebody pick a number between 1 and 10.
9.
6. So I could add 6 to it. So this is now x plus 6. But if I add 6 to one side, the scale is going to tip. So what do I have to do to keep it balanced? Add 6 to the other side. I have to do exactly the same thing to both sides. So 6 plus 6 is 12. So I've now built onto this equation to make it more complicated. Now what we're going to be doing most of the time is we're going to be giving this command, solve. And we're given that command to solve. What they're asking us to do is to take this equation here and take it back apart and get it back into this form. Well, this equation was built by adding 6. How are we going to take it apart? Subtract 6. If we subtract 6, it takes that off, and it's back to just x. But now, just like up here, if I subtract 6 from one side, the scale is going to tip unless I do the exact same thing to the other side. Subtract 6 from the other side. So 12 minus 6 is 6. So we got back to that original form, x equals 6. We solved the equation. Now on this one, we watched it be built. We built it, so we knew how it was built, so we knew exactly how to take it apart. The trick in solving an equation is figuring out how it was built so we can figure out how to take it apart. For example, we might have this, 28 equals 7y. To figure out how it was built, we find the equal sign, and we identify where the variable is. In this case, the variable is on the right side of the equal sign. Then we ask ourselves, what's keeping that variable from being by itself? Right now it is the 7. It's keeping y from being by itself. What operation was used to combine that 7 with the y? It was multiplied. So how would we take it off? We would divide. So divide by 7 takes that piece off, leaves us with y. But just like before, we have to do the exact same thing to both sides to keep it balanced. So we have to divide this side by 7. 28 divided by 7 is 4. So y equals 4. We've solved that equation. Now, if we're unsure, we can always double check. We can always go back here, take that original equation, 28 equals 7y, and we can replace y with the value 4. What is 7 times 4? 28. So we get the exact same value on both sides. So that checks out. That is the correct solution. So looking at this one, again, we find the equal sign. We identify where the variable is on the left side. What's been done to this variable to build this equation? The 3 has been subtracted from the z, right? So to solve this equation, to take this back apart, what are we going to have to do? Add 3, removes that subtracting 3. Now we're back to z. But as with the first two, we have to do the exact same thing to both sides. We have to add 3 over here. 9 plus 3 is 12, so z equals 12. And again, if we want to double check that, we can put 12 in here for z and double check. 12 minus 3 is 9, so we do get the same value on each side. Now, of course, they don't stay that simple. we run into ones like this. So just like always, we find our equal sign right there. We identify where the variable is, which is on the left side there. Now in this case, there's a couple of things that's keeping our variable from being alone. We have the 3 and we have the 7. What operation was used to attach the 3? It has been multiplied, right? And the 7 has been subtracted. Now, according to order of operations, we ask what's been done to our variable here, what's been done to x. If x were a number, what would we do to it first? Would we multiply by 3 or would we subtract the 7? Multiplying happens before subtraction, right? So order of operations says you'd multiply by 3, then the 7's been subtracted. So this equation was built by taking the variable x, multiplying it by 3, and then subtracting 7 from it. Now if you put something together, maybe you put together a model, or you put together your engine, or a piece of furniture, or whatever, and you've just finished, and you've just put on the last piece. If you need to take it back apart, what's going to be the first piece you take off? The last piece you put on. Same with an equation. We go to take this apart. The first piece we have to take off is the last piece that was put on. So the last piece put on was subtracting 7. So we're going to do what to take it off? Add 7. So that minus 7 is gone, leaving us with 3x. But because of that balanced scale, we have to do the exact same thing to the other side of it. 20 plus 7 is 27. And then, of course, we have to get rid of the 3 by dividing. 3 is multiplying the x. We get rid of it by dividing by 3. So we got x there. 27 divided by 3 is 9. So x equals 9. To double check, I'm going to replace that x with 9. 3 times 9 minus 7, and check to see if it is 20. 3 times 9 is 27. Minus 7 is 20. So we do get the same value on each side. So our solution is x equals 9. Make sense? Well, let's have you guys try one in your notes. Give that one a shot in your notes quick. See what you come up with. Yeah. Put down's right. There should be a 0 on the end of that, right? That's right. 6.210. Yep, because the linear is a 0, so you gotta have that extra 0 on it. I wouldn't mark it wrong without it on.
I think these are the same thing. Put these more inches right there.
Down this right. Something's a little off on that one. This one, it's 6 times right. That's right. Yep. Okay, so what's the first thing we have to do to take this apart, to solve it?
Minus 2.
So our first step is to subtract 2. So we have 35 equals 5y. Then what do we have to do? Divide by 5. Perfect. So 7 equals y. How many of you had 7 equals y, or y equals 7? Perfect. Well, of course. What's that? You've been paying attention. Of course it gets worse, yes. What's different here? We find our equal sign, we go to identify where the variable is, and the x appears twice. Now, fortunately here, both times is on the same side of the equation. If we're thinking of that balanced scale, the 4x and the 3x are both on the left side of the scale. So can I just push them together to make one big pile? Would that change the balance at all? No, it won't. 4x and 3x make 7x. So I can just rearrange this. I can combine those to make 7x minus 5 equals 58. Now what would I do to solve it? Add 5. So 7x equals 63. And then divide by 7. So x equals 9. As always, if I wanted to, I could double check by replacing the x with the 9. So 4 times 9 minus 5 plus 3 times 9. And let's check to make sure that equals 58. So 4 times 9 is 36. 3 times 9 is 27. 36 minus 5 is 31. Plus 27 is 58. We get the same value on both sides of the equation. Not so bad? What's different about this one? The x appears twice again, but once on each side. If we're thinking of that balanced scale, I've got 2x over here and 5x over here. I can't just push them together anymore because they're not on the same side of the scale, not on the same side of the equation. So what I need to do is literally get rid of one. Grab it, take it away, and throw it away. Easiest to take the smallest one, which would be the 2x. Mathematically, how we take something away is we subtract it. It's gone. We're left with just -4 over here. But as always, if we take something off one side, we have to do the exact same thing to the other side. So I somehow have to take 2 x's off of the other side as well. Where can I take it from? Well, I can't take 2x away from -28, can I? I can only take it away from 5x. So I'm going to subtract 2x from the 5x to get 5 minus 2 is 3x. -28. Now, what do I have to do to solve this? I've got to get rid of the subtracting 28 by adding 28. So -4 plus 28 is positive 24. And then, and then we will divide by 3. So 8 equals x. And as always, we can put that 8 back in here to double check. So 2 times 8 minus 4. Check to see if that is equal to 5 times 8 minus 28. Well, 2 times 8 is 16, minus 4 is 12. 5 times 8 is 40, minus 28 is 12. It's the same value on each side. So x equals 8 seems to be our correct answer. I'm going to have you guys try a couple. Try that one in your notes. We'll discuss it in a minute. So what do we do first? The 3x and 2x make 5x. It's 5x minus 8 equals 17. And from here, we've done this before. What do we have to do? Add 8. 25 equals 5x, and then divide by 5. So 5 equals x. And if you could double check it, it'll work out. Well, let's have you try this one. That works. Would you add the 8 first and then combine the... Yeah, that'll work. Generally, it's better to combine the x's first, but most of the time it'll work out if you don't.
I just seen it and then I looked at it and I was like,
Yeah, it'll work. Try this one in your notes. Got it. So this one, the x's are on opposite sides. We have to get rid of one. Which one's smaller?
The 2x.
The 5x. We're going to subtract 5x. So we're left with 28 over here. We have to subtract 5x over here from the 7x. 7x minus 5x is 2x. We still have the negative 2, so this is 2x minus 2 equals 28. What do we do from there? We add 2. So 2x equals 30, and then divide by 2. X equals 15. How many of you had x equals 15? You see where it came from now, Terry? You sure? Sort of?
Shit.
Try this one in your notes. So looking at this, first thing we see is that we have 7x and a negative 5x on the same side. So you have to be careful combining those. 7 and negative 5 make 2x. So you have 2x minus 3 equals 5x plus 27. Now we have to get rid of one of those. There's one on each side. Generally, we get rid of the smaller one, which is the 2x. So I'm going to subtract 2x. Now we have to be careful. What's left on the left side over here? Negative 3. 5x minus 2x is 3x plus 27. Then we need to subtract 27. The x is over here, so we got to get rid of everything that's on that side. So we subtract 27. We have 3x here. Subtract 27 here gives us a negative 30. And then divide by 3. X equals negative 10. What do you think?
I'm looking for a short stick right now.
That's that helpful attitude. My pencil's nice and sharp.
You wouldn't give it to me though.
I am really digging the tremendous support I am feeling between students in this room right now. It's amazing.
Kind of a unique one.
Unique is one way to describe it, yes. I want you to try this one quick, see how it goes. So, talk me through it. What do I need to do first? On the left side, what do I have to do first over here?
Add the 3x plus the negative 5x.
So 3x and negative 5x make
Positive 3x.
negative 2x. Anything else I can combine on the left side? No. Okay, on the right side, what do I need to do? 2x and negative 9x make negative 7x. Now, I usually get rid of the smaller one first. Which one's smaller here?
The
Negative 7 is smaller. So I'm going to add 7x. Why did I add instead of subtract? Because it was negative. Very good. So I add 7x to the negative 2x to get 5x. So I now have 5x plus 9 equals 54. Then what? Subtract 9. 5x equals 45. And then divide by 5. So x equals 9. How many people had x equals 9? A few of you?
I had way different numbers, but I
You got to it? You put it on the right side so you had negative 5 and...
No, you said it before I came up.
Oh yeah? Let's try another one? Okay. In other words, you made a couple of mistakes and it ended up being right?
Yeah.
Okay. It happens. Here, I'll make this easier on you. I'll make this a 13. There you go. Give that one a shot. What do we do first? The left side, we've got 4x and negative 6x makes negative 2x. So we have negative 2x plus 23. On the right side, what do we end up with?
7x plus negative 5x.
7x and negative 5x make positive 2x. Now what? We have to get rid of either the negative 2x or the positive 2x. Probably easier to get rid of the negative 2x by adding 2x. Leaving us with 23 here. Plus 2x here makes 4x. Now what? How many of you made it to this point? Good. Now what do we do? Add 13. So 36 equals 4x. And then divide by 4. 9 equals x. And again, as always, if you're unsure, you can go back, put 9 in for x. See what you get here. Put 9 in for x. See what you get there. And make sure it's the same value on each side. One more for you. Try that one in your notes. So looking at this, what are we going to do first? Is there anything to combine on the left side? Anything to combine on the left side? Say no. No. Very good. How about on the right side?
Yeah, the 2x and 5x.
5x and 2x make 7x. Now we have an x on each side. We have to get rid of one. Which one are we going to get rid of? Well, they're the same size, right? If I subtract 7x, it's gone here. If I subtract 7x here, it's also gone. The variable has disappeared on us. So we have negative 17 equals 3. Now, when the variable disappears, there's two possibilities. This case, I get two numbers that are not equal. Is there any value I can pick for x that would ever make negative 17 equal 3? No. There isn't. There's no way negative 17 could ever equal 3, right? So this equation has no solution. Sometimes called an indeterminate equation because there is no value. There's absolutely no number I can put in here for x that'll make that true. Now the other side of that is I can have an equation like this. I go to combine things here. I've got the 3x and the 2x make 5x. I have negative 4 and positive 7 make positive 3. Now I have a variable on each side. I get rid of it. I subtract 5x. It's gone, but this time I have 3 equals 3. Is that true? Yeah, is there any value of x that would make that not true? No, I can pick any number for x and put it in here. And 3 is always going to equal 3, isn't it? So in this case, the solution is any number. Any number I can think of. I could put 7/53 in there for x, and it'll be true. So any number makes this one true. So when the variable disappears like that, there are two possibilities. If I get two numbers that are not equal to each other, then there is no solution. If I get two numbers that are equal to each other, then any number would be a solution to that equation. To leave you on a confusing note, then, let's do the homework. On page 249, it's exercise 6.1, 1 through 59, the odds. And on page 251, exercise 6.2, 1 through 29, the odds. Yes, sir.
I don't know if I did them right.
Okay, so you point to. Okay, this is a standard. This is 0.25.
And then you had this.
Plus the 10. It's 0.01. And this is a 3, so 3. This one's metric. So this is 5, that's 6.0. So it's over past a half point. And over here it's 20, there's a 21, so 0.21. And then this lines up with 0.
Where did you get the 20? Oh, because
20, this is 21. We line it up on
Yeah, we
the
go
axis.
to the
It's
smallest
the
one.
21 that lines up, right? It's actually dead on the 21. And then we go over here to get the third digit, which is the 0 that's lined up. So that's where we put the 0 on the end. Like here we got 3, that's where we put the 3 on the end. Just to add those all up to make sure. Measure here. Measure those up to the measure. Let's take a look at what you got for everything else. Those are good. That's good. This one should be 0.4. This should be 0.3.
386. 487.
This one is 6.5. And then plus the 32.
What is it? 25.
This is 1, 2, 3, 4, 5, 6, 6.5. 6.5.
Oh, okay.
That's the half mark. You got the. You read it right. You just needed the half mark. 6.5 plus the point.
Okay.
And then this is 7, 8, or 6, 7, 8, 9.2. That's the 8.
Oh, yes, 9.
Take a look at it. See if we can fix those.
Alright.
Thanks, sir.